of this year are awarded or are selected. And we already know 3 Nobel laureates announced the last days. I know that mathematics actually is not among the disciplines awarded with Nobel Prize, but I would like to know that mathematics is the mother of all sciences. And as a mother, mathematics agreed to give all Nobel prizes to children. And I find this a good sign. Actually, it's we speak today about the Institute of Mathematics and Informatics, and I would like to know that the Institute has impressive history, 60 years, and the 60 years actually of impressive development, and just to underline that we have specialists that are known in the world, in the whole world. Institute of Mathematics and Informatics succeeded and succeeds to keep alive 3 journals. I mean, nowadays it's difficult just one journal to provide its existence and continuation and so on. But the Institute of Mathematics and Informatics here shows really excellent activities, and among the best institutes, I mean research institutes over the last, let's say, 20 years, the Institute of Mathematics and Informatics was always among the first 3 institutes taking into account their achievements. Because each year, by the end of the year, we analyze the results, and taking on the basis of those results, Institute was always among the first institutes. But if one would take into account all features of activities, I mean, the published papers, the resonance of those papers, so the management of science in the institute, and here the institute really was an example, because I'm sure that the employers go to the institute with pleasure. And I've always visited the institute, and each my visit was like a holiday, because always in the institute was a very pleasant atmosphere, and I would like to congratulate today the researchers and all the employees of this institute for their excellent activity over the years, for their achievements, and I, with regret, would like to know that in this conference hall we have a limited number of researchers, because some years ago the number was obviously higher. But let's explain this in such a way that the quantity goes down, but the quality goes up. And in this case, everything can find an explanation. You see, we live in, now we are in the 21st century. Actually, the importance of science becomes more and more evident. And you know that there were meetings of leaders of the world to find solutions to challenges that we face nowadays and so on. And there was a decision of the General Assembly of the United Nations in August 2023 proclaimed that the International Decade of Science is for Sustainable Development. By the way, we will organize an event to launch this international year. And of course, we should develop further science as a whole, and mathematics as mother of all sciences, because without mathematics, you know, nowadays all people speak about artificial intelligence, and well, the Nobel Prize, by the way, not in mathematics, but in physics, was awarded to people that practically developed the basis of artificial intelligence in some way, of course. So my conclusion is that the Institute of Mathematics and Informatics continues its activity in, of course, the situation, financial, and nowadays this region is not the best due to many, you know, that we have war in the neighboring country, economic problems and so on, but nevertheless, the Institute of Mathematics and Informatics continues its activity and remains one of the best research institutes in the Republic of Moldova. And on behalf of the Presidium of the Academy of Sciences of Moldova, I would like to congratulate all the researchers, the employees of this institute with this anniversary, and of course to wish much success in the future, good health to all collaborators, and to keep life to continue, because the situation is very dynamic. Science is needed. The results of scientific investigations are needed by the society, and it's very important to do the best to attract young people in research and to provide a basis for future developments. I would like here to thank foreign guests. Well, we have guests that cannot be attributed to foreign guests, but because even academician from Yash cannot be attributed to foreign guests, because here we are in a common friends, and we develop a very close collaboration. And by the way, two academies, Romanian Academy and the Academy of Sciences of Moldova, we have a joint plan of joint actions, and many events, many conferences we are organizing together during our efforts. And that's a good example for how people can succeed more by joining the efforts. Now, there was a decision of the Presidium of the Academy of Sciences of Moldova, and taking into account the success, the achievements of the Institute of Mathematics and Informatics over the years, taking into account the resonance of the results published by the researchers of this institute. We came with an award. We come with an award, and I will read first, and afterward I will ask the director to. So, the Excellence in Research Award to the Institute of Mathematics and Informatics Vladimir Andrunachievici of the State University of Moldova însemn de înaltă recunoștință pentru realizările științifice valoroase, promovarea cercetării la scară internațională și pregătirea cadrelor de înaltă calificare pe parcursul a 60 de ani de activitate. So this is the award. The Institute of Mathematics and Informatics achieved the highest level in research, and of course we wish to keep this higher level in the future, and to contribute to the promotion of good image for the Republic of Moldova in this century that is actually a century of many challenges for people on our small planet. So, the director, this is for you, my brother, please stand here. So, congratulations. Thank you.
Thank you, Mr. President. And now, the next speaker is Vice Rector for Digitalization from our Moldova State University. Please, Mr. Secretary.
So, dear President of Academy of Sciences, dear colleagues, dear friends, I will not start with an official speech. There's a lot of reasons why, but main, I think, is that my first record in my employment registry, it's not traductible expression, was written here in the Institute of Mathematics. I was a student of, I don't remember exactly, fourth or fifth last year of study, and I already started my work here in the Institute of Mathematics of Sciences at that time. So this is first cause why I want to say thanks a lot to the Institute of Mathematics. During the years, Institute has a lot of performance in different kinds fields of mathematics, traditional applied mathematics and computer science. I will not enumerate these results, the famous names of people who are working now here, except three names, which was my supervisors at that time I started my first job. Mr. Gandhi, Mr. Bishkoi, and my brother, Draco. So I have family relations with the institute. It's very closely connected. I want to say thanks to Institute for perfect journals which are published and are edited by the Institute. First of all, for Computer Science Journal of Moldova, and for a journal in quasi groups, which is edited in collaboration with Polish, I think, Polish colleagues. A lot of projects, national projects and international projects, and I'm proud of the direction and the topics of this project, which are oriented to the most important directions in contemporary informatics and mathematics. Language, natural language recognition, analysis of human language, and connections to artificial intelligence. By a list of projects from Institute side. And as representative of head organization of Moldova State University, I want to say once more welcome to big family of Moldova State University, and I hope it was not an absorption. It was coming into a bigger family of researchers and young students in the field of mathematics and computer science, which can help the institute to become younger, became more dynamic, more successful, and reliable for next years. 60 anniversary of 60 years is a great university. It is a great anniversary. So I hope, but after 10 years, our conference will be a bit bigger by number of participants. Will be a bit younger by age, and will be a bit older by experience and competence. Congratulations, Institute of Mathematics and Computer Science.
Thank you. And with this, we can close our official opening of the conference and move to our next part of the conference and open a plenary lecture with our invited speaker from the Romanian Academy, our good friend for our institute, President Member Dan Christian. His research is in the domain of discourse structure, incremental discourse parsing, the relation between structure and the reference, anaphora resolution, operational lexicography, and including all Romanian documents. Please,
Good morning, everybody, and congratulations for this magnificent celebration of 60 years. For a man, this is a young age for an institute. It shows the mature of your activity. Continuing the speeches that preceded mine, I could refer to the links existing in between your institute and Romania. There is a very well welded cooperation in a triangle, Chisinau, Iași, Bucharest, and I am extremely happy to tell you that we are doing this collaboration since many years, and especially in my domain, which is natural language processing, together with the institute that has been headed till recently by academician Andrunachievici in Bucharest, and now is followed by the younger Andrei. We had a common research with Chisinau, and especially dedicated to the promotion of the Romanian language through technical and informatics technologies. I think there is a problem with putting on the full screen. Okay. Thank you very much. So, as you perhaps have seen, my speech will be entirely informal, and I want to refer to my thoughts about this extremely attractive development in artificial intelligence that come from large language models. The next two slides announce an event that was happened, and the president of your academy has mentioned already. Two laureates of Nobel Prize were congratulated for their contribution to artificial intelligence. Only that the prize are given to in physics, not in computer science, because Nobel, you know very well, doesn't have this domain among their domains. There is, of course, the Turing Award, which actually Hinton, Professor Hinton has took it already a few years ago. But it's very interesting that people think that contributions to the domain of computer science should be awarded at this very high level. So, of course, this last generation that of systems that I want to talk about is headed in these models of that are called large language models, suggesting by this title the fact that they include a huge quantity of text that has been previously processed in order to acquire the capacity of keeping the dialogue a vibrant one that means very well that with a human a developer, and they refer to natural language, but this does not is restricted to text. It includes art, dance, Morse code, genetic code, hieroglyphics, Christograms, sign language, body language, musical notation, and so on. So a lot of variants of language, all meant to communicate between humans and now between humans and machines. Programming languages also, which is extremely important. They are trained on an extremely high amount of data, billions of parameters, a parameter being neural network, and they are able to predict and produce text and other media based on the input they receive, which is called a prompt. They engage in conversations, answer questions, and write code. I remember 1 year ago I was in the University of Wales, where we placed one of our summer schools, and I had an invited speaker there from a director of an IT company in Iași, and he was telling me that since the appearance of this technology, his company gained 85% increase in productivity by the code writing, programming code writing, helped by LLM models. Okay, yeah, actually these models, they mainly learn patterns, structures, and nuances of language. And you may compare it with the humans, which do this with the rules of grammar, wisdom of poetry, or the jargon of technical manuals, just to give a few examples. They do this mainly by predicting the next word based on the previous words of the sentence. And to have an idea of the growth of this area, look at these figures. Only from in the last 4 years, but all happened during 2 years actually. This technology had an extremely large rise in the dimension of starting from 1.5 billion parameters and arriving nowadays to 1,000 billion parameters to GPT-4. And here is a graphic showing the revenues coming from this domain. We are here in 2024, and you see the prediction for only 8 years going from more than 1,000 times bigger than nowadays. And this is not a 4 years time domain. It all comes from the old AI, artificial intelligence, mostly oriented for giving the machine the ability to reason and solve problems. Maybe you remember the field of AI, who at the beginning was oriented towards theorem proving. It's a domain which even now is very difficult to be handled by LLMs. And they started to model such-called toy problems, very tiny and small problems that have given solutions with AI tools. But the researchers soon realized that the models they invented are not proper for real-world problems, which are much higher and much diverse. And one of these bottlenecks is called common sense coming from the impossibility to reflect with symbolic means the diversity of the common sense rules, and for years the AI has been characterized as having an AI bottleneck because people realized that it is impossible to introduce by hand all the diversity of situations that are characteristic to our world. In the modern approaches, these neural networks, which resemble the human brain, with the deep learning paradigm, and especially to the new generative transformational approaches, are trained on an amalgam of text. And I make this comparison with a hovercraft, this large air cushion machine that goes over bumps of land. This is how, in my imagination, these neural networks are able to solve the diversity of situations they encounter in language, which time ago was done by multiple symbolic rules that were introduced by hand. In the first years of life, compare what happens with the children which learn to speak in their mother's tongue, and what they do, the idiosyncrasies of language are usually encrypted in neural networks. So training neural networks as a general machine only to understand language or a special language, and then same as a child goes to more and more specialized schools up to the faculty level, the neural networks may, to those already trained, you may add supplementary layers that contributed by particular texts, and these are able to specialize the model in certain directions. Now, just a few things about because I'll tell you good things and bad things about LLMs. The strong facts that are widely recognized is the fact that they have a big potential in scenarios where there is a need to analyze, process, summarize, rewrite, edit, transcribe, or extract insights from data sets or text inputs. And some areas that I could mention, only a few of them, are, for instance, translations. For instance, I recently had voices that make the statement that GPT-4 outperformed the commercial translation services like Google Translate, which has spent many years to train an artificial translator. And it didn't come for free because it has a long history before. Then the generation of content in articles, blogs, summaries, scripts, polls, quizzes, and so on. The search is a very powerful search machine, which because it finds information, makes analysis on almost any subject. Actually, in all my dialogues with GPT, I was not once that I could give a negative answer. I don't know it. They are not trained to say that they don't know it. When they don't know something, they hallucinate. Okay, they invent things. The model, I mean. Okay, then in the detection prevention of cyber attacks, for instance, this new development of the company Sentinel-1, which detects threats and launch automatic reactions to malicious activities. Code generation, as I told you already, what director of an IT company said 1 year ago only. And actually, I had a discussion with Daniel Markovich, which is one of the most famous scientist in America now, but he's Romanian, telling me the jobs in IT dropped down fantastically. So we may expect that because the productivity increased so much, so we may expect dramatic changes. And this includes also the education, higher education in computer science. I see completely transformed in the years to come. But there are also often pronounced discontents. And I summarize here only a few of them, which some of them are not actually true. For instance, in the translation, it is well known that these models behave poor with distant languages, which are not in the same family, or with low resource languages, which it is called low resource if their visibility in the internet is not very high. In the domain of search, user attempting to use ChatGPT for search reasons like Google or Bing should be very attentive, because not everything that is returned to him or her is true. As I told you many times, these models hallucinate. Content generation, they're prone to hallucinations also. Models do not truly understand language. They operate based on patterns. The quantity of their outputs can be inconsistent, sometimes leading to illogical or nonsensical responses. Complex reasoning, it's a very hard time for these models, because it requires understanding beyond literal meaning for which they are trained. So because solving a problem is not applying some patterns, you have to have new ideas. This makes this area very difficult. Then they have also memory limitations, for instance, not being able, people said, to link different sessions of the same user. These are complaints, but as I told you, not all of them are true. And linguistic hurdles, these I recognize, having difficult times with idioms, coordinations, figurative language, all these aspects of a language which a human master when it's her native language is difficult to be handled by these models. Privacy risk also. So let's play a little bit with ChatGPT 4.0, they call it like this, which is the last version of ChatGPT. You have 3 sessions for some times, and then you are limited. So, but I try to, okay, I had to come again next day in order to continue the dialogue. So one of the blames which is addressed to these systems, and they are very bad in doing mathematics. Gives incorrect answers to prompts asking to perform computations. Let's verify this. I have given him this problem. I have 11 cats and and I bought 2 foxes. 3 cats ran away when they saw the foxes. This engaged a certain confusion among foxes, and 1 went away also. Finally, 1 cat returned. How many animals do I have now? And the answer from ChatGPT was, let's break it down step by step, okay? And it gives you very sharp explanation to each step, what is happening. The 11 cats and 2 foxes, you have 13 animals, then 3 run away, you remain with 10, then 1 fox came back, so you have 9 animals, and then 1 cat returns, now you have 10 animals. And it gives you the correct answer, which is 10 animals. So they are very good in doing computations with small figures. And I understood from contesters of ChatGPT, they are miscontent of their abilities to operate with high figures. So I have given these a few examples. I will reproduce only one here. And I asked him if 97,819 is a prime number or not. And he tells me no, it is not a prime number, which is true. And to convince me for that, he reproduces the Python code that he has used in order to demonstrate this. So as you see now, okay, for each of these dialogues that I reproduced here, I wanted to see how it is made. I mean, how I imagined at least if I not have enough information, and I mimic this, you know, National Geographic series of episodes of how is it made, showing a lot of technicities. Okay. The straightforward solution here with the mathematics is that LLM also apply call for Python API. Okay, therefore it is a combination between a trained model and some code. Okay, but you have to know when and what to ask to an API. Factual information. So the contestant said that since GPT is trained on fixed sets of data, it cannot keep up with fresh information. Let's verify if this is true. So my question was this. What was the famous music festival that went on in Bucharest in September this year? Very new information, 1 month ago. And GPT-4 tells me about the Georgianescu festival, a lot of details about how we developed there, and the fact that it is one of the, even that Romanian composer Georgianescu is very famous and so on and so on. And it also reports me 4 sites from where he has taken this information, you see? So now it has the capacity to appeal to the internet, to information which is displayed in the internet, which was not the case with the previous versions of ChatGPT. So let's try another question. Because people said they hallucinate when they don't have this information. I have found this question in a paper. A user or a blog, I don't remember, was discontent about the question that who was the US president during World War I, and he started to hallucinate. But now the system gives a correct answer, okay? So it has been, again, I come back to ask how it is made. The obvious solution is to make use of existing knowledge on the web, because you are trained indeed on fixed amount of textual data, but when you receive a factual question, it is very easy to make use of the internet and look for information there. So first you must find the right pages, and then to summarize an answer consulting these pages, which is very much in the LLM's inner paradigm. Now, knowledge of syntax. Everybody knows that LLM models are extremely fluent in many languages, especially the most popular languages, well documented. But people say, blame them that they are poor at mastering syntax at a conceptual level. Let's verify this. My question was this, is it an error in the sentence, the key to the cabinets are on the table, the key, not the keys. And he tells me that indeed it is a mistake because he explained that the correct, the key to the cabinets is on the table, not are on the table, because the subject should be in correspondence with the predicate, and since the subject, which is the key, is singular, the predicate, the verb of the phrase should also be singular, okay? So it has, you see, it has the notions of what is the subject and what is the predicate of a sentence. Now it has conceptual knowledge about syntax, not only practical knowledge, I mean the usage. Okay, so how is it made? For a long time, people has dealt with putting syntax into AI and have developed more and more sophisticated models to do that. So now I mentioned here only two such very modern models, recursive neural networks, particularly the tree-structured RNN, which are able to indeed extract the syntactic structure of the sentences. And so there are very recent studies on this domain, but this proves that the conceptual knowledge that an LLM system has on syntax is because they are coupled with these models, okay? So it's not only a matter of working on text. Important question about the object permanence and physical world consistency. And the blame here is that they are notoriously bad at mastering common sense. Let's verify this. If I put a book in a box and then close the box, and after that I open the box, where is the book? So of course the book should be in the box. The system recognizes this, okay? But this was not all the time like this. I mean, because it can give you the impression that it is no more there if I close it, okay? But it remained where it was put initially. So how is this object permanence being made? Because you have to have a certain knowledge of the real world in order to give correct answers to this. First, how we humans do it. We acquire common sense by our day-by-day interactions with the exterior world. From the child till the reaching maturity, we learn the laws of the physical world. Okay, the physical world is around us, and we are forced to learn them. If I drop my telephone from my pocket, it will fall down. I learned this at a very young age. Okay. A system that uses language is not aware of this, so it must get it from somewhere. Then this knowledge helps the child to correct deduction, even in situations which hide details, okay, and to make correct deductions. And then the LLMs, how they do it, I am inclined to believe that linguistic knowledge, the one that is abundantly fed into this system during training, also brings exhaustive common sense and knowledge to allow coherent and natural dialogues on any subject involving physical world. This is put as a question. Can we do that? Can we make this position? Perhaps in many cases this is true, because expressions about how the physical world behaves appear many times in language. But does this idea solves the much debated AI bottleneck that I mentioned before? This is still an open question. It has to be seen in the future. And there is a recent example with this, everybody knows IBM's Watson, which integrates rule-based system to assist in complex decision-making processes. So perhaps again, we have a mixture between LLMs and rules that are in some cases introduced by hand. But the majority of knowledge about the world perhaps comes from the language itself. Okay, spatial awareness is another factor of common sense and positional reasoning. And the blame is that LLMs lack real-world awareness, again, which make them clumsy when reasoning about object positions, leading to flawed conclusions about spatial arrangements. Let's verify this. And I have given to ChatGPT for the following problem. Suppose I have a table with a chair on the right, like here. You see the chair here. Is the cursor seen? No, it's not seen. Okay, the table with a chair on the right and an armchair on the left. Okay. Now I sit down on the armchair facing the window. Okay. Is the table to my right or to my left side? Here the scheme shows where it is, and GPT-4 responds very correctly based on the scenarios and your description. If you are sitting on the armchair facing the window, the table will be to your right side, which is true, since the chair is in the right of and the armchair is in the left of the table. Okay. So it has the capacity to appreciate spatiality and the position of object, which is also not something that is easy to be done. Okay, how is it made? Maybe it is plausible that this awareness cannot be obtained solely by linguistic training, because the diversity of situations is infinite in the physical world. So my belief is that they incorporate a sophisticated spatial model, and there are, to give just one example, well-known AI-driven geographical information systems in models today. So again, a conglomerate between something that comes from neural networks and something that comes in a different way. Situation tracking. The blame here is that same as with real-world awareness, LLMs face challenges to track entities that participate in a discourse for updating their relative positions. Let's verify this. Me, I said. A cat is on a horse. They are riding. The horse falls down. Where is the cat? And look here, please read if you can this answer of GPT-4. See how accurate answer it gives. Okay, not only detecting the position of the possible positions of the cat, but also giving some varieties of in case the cat behaves differently. But knows also that the cats always land on their feet when they fall. So this is a thing that they know very well. And so how can this be done? It is a known fact that difficulty to model situations in LLMs, and this comes from two directions, has been recognized by many researchers. Two of them very recent papers of this year, Lapin and Maho and others, said that this difficulty comes from the fact that the extracting information from many sentences in a row, because the model is not able to concentrate this diversity of information, the length of the text, and then integrating the incoming English to dynamically update information about entities, okay, and their states, which gives you the supposition that perhaps these models keep updated a database of positions of situations. This is how I would do it. And there are some researchers that recognize this possibility. Okay, summarizing long text. Again, some voices said that it has long been argued that LLMs are not able to keep track of facts related in a text at distance. Okay, and I wanted to verify also this, and I asked him a question about a book that was extremely much studied in my laboratory with my students. Is this the map of the invisible world, a book of about more than 300 pages, I would say, belonging, written by Kershaw, an Indonesian writer. This book it's very interesting because the author changes very fluently, very frequently between the present time and the past time, and goes to the past and comes back in the present, and so on and so on. And my question was about the three characters in the book. Adam, which was the son of Carl. Carl has taken Adam from an orphanage, and Margaret was an acquaintance of Carl, with whom he lived for some time. But before that, Adam came near Carl. And actually, the book can be explained on this scheme, because this is a map which is proved to be possible to be extracted with symbolic means from text. And with my colleagues, my PhD students, I have written invented this theory that we call it time yards model, to develop the, development the developments of a character during a book, from the first page to the last one, okay, and they can be traced on different yards, on different traces, like the trace of a train in a railway station. You see, for instance, this one follows Carl's trajectory. This one is Margaret trajectory. This one is Adam's trajectory. You see? And this one is Adam's young brother, Joseph. What happens there is that at a certain moment they were in an orphanage. Adam was in an orphanage, and at a certain moment they were separated, he and his brother. His brother was taken by another family, and he was taken by Adam, okay? By Carl. Carl was, Indonesia was a former Hollandaise colony, and he was a Hollandaise origin there, but they lived in Indonesia. Okay, now you see the track of Carl meets the track of Adam from here on, okay? They stay together for a while, but at this moment, there is the savage revolution there, and Carl is taken in prison by the inner riot, okay? And then it disappears from the book. Is this this line that is dotted line, and then after the disappearance of this father, Adam goes to find Margaret, that he knew from his father, that was very close to his father. So he goes to find her, and they meet. Actually, they meet. But this is the moment when they meet, and you can see now that in my question was at the moment when Adam meets Margaret, was Carl around? It was not. He was not there because he was in the prison. Okay, and but the extraordinary fact here is that this conclusion, you can do it if you read the book. Of course, as a human being, you can have this conclusion. But how does an artificial agent can do it? Because it's not so easy to relate moments, and there is not a moment in the book when there is the answering of this question. Okay, You have to deduce it from the other facts. Okay, so how could it be made? Because I'm not sure. But actually, my idea is that they use already long-studied models about time that had been used in language. And indeed, this was the logic of time. Everybody maybe has heard about James Allen's logic of intervals, and also the Pustoyevsky's and his team notations about the time in text. And from here on, the domain evolved very much. And I'm certain now that the developers of ChatGPT series have used these techniques. Okay, I don't know how I stay with the time. Perhaps I'm a little bit, yeah, I have to finish. So I'll skip a number of things, theory of mind, which is very interesting things, and I will go to my conclusions and saying that all these things can be put into 4 categories: capacity for formal reasoning for world, mastering the world knowledge, situation modeling, and social reasoning. And the idea is that many of the blames still recently put on the back of LLM are obsolete. Okay, they are doing very well with them. And therefore, we are on the realm of augmented LLMs, except for one, reasoning itself, that in the recent implementation of LLMs still have drawbacks. And many of these features result in a byproduct of scaling up to huge amounts of training data. Okay, I can recognize this possibility, but they also, I'm sure that they also use complementary symbolic way of reasoning, and therefore making this neurosymbolic symbiosis that people started to talk about. Okay, thank you very much. I want only to invite you to our next conference in Alba Iulia. I will be in 14-15 November. And in next month, actually. Okay, Alba Iulia is a wonderful town where you have these fantastic cetapea, so the old castle, call it. There's also some Roman vestiges there, and we have decided to place. We had last year we had it in Chisinau. You remember very well, yeah. Okay, and then some acknowledgement addressed to my colleagues. Thank you very much.
Thank you. Have some questions, please. Please.
Related to artificial intelligence and languages, large languages models, there is difference between how machine learning learns and how people learn.
Sure.
Machine learning is connected only, connects reasoning only to information. However, people are connected with information and with reality.
Sure.
Is there any approach to connect machine learning to reality, to real physical world?
Mm-hmm. Yeah, I could tell you only in the domain of interpretation of videos, for instance, which brings a little bit of reality into the scene. And now there are aligners built to align text with these videos. And from this alignment, it's clear that you can gather something from the reality around. Other means to acquire our reality I'm not aware if they are used or not. Yeah.
Also here, one more question, sorry. Recently it was observed that the quality of predictions of machine learning was greatly dropped.
Can you tell me again?
Because they learn from open source data, which can be also output of other predictions made by machine learning. So they are trained on less qualitative data and produce even less qualitative results. Recently, online services ask uploaders to specify if their result was produced by artificial intelligence or by human intelligence. Is and it of course damages also human knowledge, because if people learn from less qualitative data, we can go very far. So is there a way to distinguish the good data from bad data in mechanical artificial intelligence from its point of view?
What do you call good data and bad data? It's very difficult also for humans to know to distinguish. In classical AI, they used data which were previously annotated by experts, very well. And so, in order to infuse, let's say, to make a machine to understand a certain phenomenon, they used a large quantity of data that were very attentively annotated by experts. Okay, putting this is a subject, this is for instance, referring to syntax. Okay, this is a predicate, and so on and so on. These were annotated in XML or other things. But mainly LLMs use unannotated data. Okay? They learn language, just the regularities of language. This makes the primary training, and then the supplementary layers are added. Okay, and there perhaps they can have contact also with some annotations. Okay, but in order to make automatic distinguish between good and bad data, myself, I don't know what is good and what is bad. So you have to decide, because one could say in one direction and the other could say in a totally different direction.
Please, Mr.
I have a very short question.
Huh?
I have a very short question.
Yeah.
What about the ability of this AI to prove theorems?
To do what?
Prove theorems.
Prove theorems.
Yeah.
Yeah. You know that I started with this, I think.
Yes.
Yeah. And I'm showing that in the old times, AI, this was the main concern, proving theorem. This was the first program that were developed. Okay. Myself, I did that with a student of mine, using rules developed by hand. I was able to prove some a small theorem in rule-based systems, but not in LLMs. LLMs are not able to do that. So in order to arrive to that ability, you have to combine them with some symbolic means. This is my opinion. Maybe if you have an extremely large quantity of theorems and proofs, demonstrations, okay, you could align these two and arrive with a model capable to infer, to induce the capacity to demonstrate, to prove theorems. Okay, this could come in time. It's just like exposing, suppose a clever young guy, okay, to a book of theorems and proofs. just giving him this book, he could learn how to do it by himself. Okay, and this is the way to do it. I mean, learning by examples. Yeah. Okay. Thank you very much. Sorry.
This is not done in the
It's not done.
I mean, in the actual system, this is not incorporated.
No.
Not done, not yet.
No. As far as I know, it is not yet.
But one of my students in Germany, he was involved in a project where they want to put this kind of system.
Never heard. Okay. Thank you very much.
Okay, thank you again, Professor. And our next speaker is Professor Felix, Professor of Mathematics and the head of the Department of Mathematics and Computer Science from Norwegian University. And the main domain of the Professor Felix is the theory of quasi-group and the theory. Please, Professor.
Thanks. I suppose I can get started while this is being set up. So thank you very much for having me, for attending. I thought I should tell you that very serendipitously on the 60th anniversary of the Institute, it's also, this year is also my 60th birthday, so the gods were smiling on me with this talk. The Institute and I were both founded in 1964. Thank you. And, okay. All right. I was going to say it's also nice that I followed the ChatGPT talk because this talk was totally written by ChatGPT. That's not true, small joke. I've changed the title from what's on the program. I wonder if ChatGPT could make a pun like rings and things. It's funny rhyme, I don't know. And I switched things a little bit because I'm going to talk beyond just rings. I'm going to talk about other numbers. I see. Okay, so my idea when I give a talk to a general audience is to make the talk as self-contained as I possibly can and generally accessible. So hopefully you'll be able to follow along. And I'm going to start from scratch. So I'll begin with the definition of quasi-group. Probably math people here will understand the definition. Others who might be new. This is the standard definition of quasi-group. You can read it there. I'll just tell you that in the finite case, this is equivalent to the Cayley table being a Latin square. So one way to think about this definition is that it is heavily combinatorially inflected. So it somehow is lacking algebraically. But mercifully, there's an equivalent definition that's entirely algebraic, and here it is. You certainly don't have to memorize this definition for the rest of the talk. The point of it is that you can understand quasi-groups as sets with operations, in this case binary operations, satisfying identities, in this case 4 very simple identities. So piggybacking on the last question, this means that quasi-groups are amenable to the incredibly powerful techniques of automated theorem proving. So a sub-theme of this talk, it will not appear, I think this is true, it will not appear on any slides, and I will only subtly mention it from time to time, but it's a dominant sub-theme, is the role of automated theorem proving in mathematical research. And then also it's sort of its obverse image, which is finite model building. We'll get to some hard questions about that towards the end. All right, I'm not going to say anything about quasi-groups. I'm going to talk about loops, and a loop is just a quasi-loop with a two-sided identity element. Mathematicians think of loops as non-associative loops. The operation doesn't have to be associative, is the point. So, so you may be unfamiliar with loops. So I'll begin with examples of two classes, in fact, varieties of loops, one of which I know everybody in the room knows, namely groups. So groups are loops that satisfy the familiar associative law. Here's another variety of loops, the Moufang loops. So they're loops that satisfy this additional identity, Moufang loops. All right. In the world of non-associativity, the equations can get messy really quickly, and they're hard to read. So here's a very modest notation simplifier, and it's just this. We allow juxtaposition to take priority over other arrangements of products. So for example, this shorthand expression you see before you is really shorthand for the longer, more cumbersome expression. All right, so for the rest of the talk, all the slides are, the notation is compactified. And it's not crucially important that you have the actual equations memorized, but that's the convention. All right, so in the title of the talk, we used the hyphenated bowl Moufang, so I want now to explain what that means. So this is an identity called the left bowl identity. It's a very prominent identity in non-associative algebras. I think that the first person to come up then was Bohl himself from finite geometric considerations. Now it's an entirely legitimate algebraic field of inquiry. So the left bowl. If you look at the mirror identity of the left bowl law, you'll get, not surprisingly, the right bowl law. So I don't know if you can do that arithmetic in your head, but it's just a mirror identity of the left law. So the next one is maybe a little surprising. Just on the previous slide, I think I had one Moufang identity. Now I have four. Each of the four is distinct. On the other hand, some fancy algebra. Each one of these identities implies the other three in the variety of loops. So in the variety of loops, each of these four identities is equivalent to the others. So there's four Moufang laws. All right, so you'll know, I'll just go back one page. You'll notice that these six identities are distinct, but they share a lot of common features. So I'm now just going to list the common features that they share. So the first is that they contain just one binary operation, the star, if you will, not the slash or backslash. The second is a bit of a mouthful, but each of the equations has three distinct variables on each side of the equal sign, one of which appears twice on both sides of the equal sign, and the other two appear once. And then the third condition is that the variables appear in the same order. So the only thing that differentiates the left-hand side from the right-hand side in these six equations is the way the equations are parenthesized. So because these commonalities come from these six very important identities, we'll call an identity that adheres to these three conditions a Bohl-Moufang identity. So it's an easy counting problem to add them up, and you can see that there are 60 of them. So there are 60 Bohl-Moufang identities. So I'm going to talk about the solution to a problem. This is not the hard problem. I'm working towards a hard problem that will occupy the very last slide that we'll talk. So this is sort of a warm-up problem to have a look at a picture, basically. So we want to classify the varieties of loops that are axiomatized by a single one of these 60 Bohl-Moufang identities. So in principle, you could use each one of the 60 Bohl-Moufang identities to axiomatize a variety of loops. So in principle, there are 60 possible varieties. That's something you could get. You end up getting far fewer than 60 because many pairs of them are equivalent in the variety of groups. And I'll give you the Hasa diagram that shows that whole solution. Serendipitously, again, sort of the first, the Hungarian mathematician, very difficult name to pronounce for anyone but a Magyar, but Fenyevs published the paper that almost classified them. He had a couple of gaps. And Wojciechowski and I cleaned that up, I guess it's been 19 years ago. Here's the Hasa diagram of all 14 varieties of bowl Mufang loops axiomatized by a single identity bowl Mufang path. Okay, so how to read this? Firstly, you kind of, as you go down, that's implies. So for example, if I had a laser pointer and pointing at the associative ones, that's the groups. So if you're a group, it implies that you're extra. If you're extra, that implies that you're both Mufang and C. If you're Mufang, that implies you're left bowl, flexible, right bowl, and so on. And so on with the other implications. So what would it mean? What would it mean to prove this? You have to do a lot of things, none of which is too difficult, but there are many things to do. You would first have to show that all of those implications that I just claimed hold. You then have to show that there are examples of the more general varieties that are not the more specific varieties. So for example, you would have to produce a flexible loop that's not Mufang. And then you would have to also show that some of the pairs of identities are actually equivalent. This is what you get. So it could feel like an exercise like this is something like stamp collecting, and I get that. Oh, by the way, the proving and the counterexamples, you have to ask the right question and know how to tease the answer out. But that's a problem that's 100% amenable to a computer. You can use automated deduction to prove the theorems and finite model builders to generate the distinguishing examples. All right, so to move beyond just stamp collecting, classifying, a diagram like this can be kind of insightful. So we've drawn this diagram in a suggestive way, but you can see that the Mufang loops and the C loops occupy kind of analogous positions in this Hasa diagram. And you can see that the left bowl loops and the left C loops occupy kind of analogous conditions. And it turns out it's actually genuinely suggestive, that relationship. So just explicitly, we know a lot about Mufang loops. Before this, we didn't know much about C loops. But using the analogy Mufang to C, you can use some of the results about Mufang loops to suggest some structural properties of C loops. So to move forward, I'll just say that of these 14 varieties, many of them are incredibly well investigated. You could do a Google search and get millions of hits for associative loops, those are the groups. Maybe even hundreds of thousands of hits for the Mufang law, the bowl law, alternativity and flexibility. On the left-hand side of the Hasa diagram, that tree, those are pretty well investigated. On the right-hand side is these weird symbols, L, N, S, M, N, S, R, and S. I'll explain those in due course. Left C, right C, and C, less well investigated. After we finished this classification, we kind of plucked the low-hanging fruit and wrote some nice results about the C loops. But it's left until very recently kind of a hole in the literature. The 5 varieties in the bottom right-hand side of the screen were really not very well investigated at all. And one of the reasons they weren't investigated is that until you had a picture like this, it wasn't clear that they would be worth investigating. I'll tell you what the acronyms LNS, MNS, and RNS mean, and they'll come back. They'll recur later in the talk. But LNS stands for left nuclear square, and MNS is middle nuclear square, and RNS is right nuclear square. And I didn't say that on the slide here because at the moment that won't have any meaning. I have to give a few more definitions for that to resonate. So I want to talk a little bit about the C and the left C laws. I'm going to focus on the left C laws. So here they are. So these are four. So you have not seen them, at least not today. These are four new Bol-Mufang laws, and it turns out they're equivalent to each other, and so each one of them axiomatizes the variety of loops that Penyev's dubbed left C loops. So you can think of the mirror image of each of these four laws, and those would be the four right C laws. A loop that's both left and right C, Penyev's called it a C loop. Nobody knows where C comes from, perhaps central. Maybe it was the first letter of his girlfriend's first name, I don't know. But the name has stuck, the left and the right, for obvious reasons. It turns out that there's a single Bol-Mufang law that also axiomatizes the variety of C loops. So I put it up here for convenience. So here are 5 more Bol-Mufang laws, 4 of which axiomatized left C laws, and 1 is the C loops. All right, so I mentioned left, middle, and right nuclear square. I was putting the cart before the horse. I should tell you what the nuclei are. So in an arbitrary loop, the left nucleus, so that's a lambda for L left, it's the set of elements that associate with any pair of elements in the loop. On the left, the leftmost argument. So you can now probably guess what the middle and the right nuclei are. So n sub mu for middle, again, it's the set of elements in the loop that associate with all pairs of elements from the middle slot. And then I'll bet you can guess what n sub rho is. It's the set of elements that associate with pairs in the right-hand slot. If you intersect all 3 of these, it turns out they're all subloops. You get, well, you can just drop the self-script that I wrote out and you see, just to be explicit, the nucleus. The nucleus is the set of elements that associate with all pairs, regardless of the argument that you put that element in. All right, so here's then a theorem. It seems like a modest theorem, but well, here, I'll read the theorem and then I'll say something about it. So in left C loops, the left and middle nuclei coincide, and it's in fact a normal subloop. So that seems like a modest theorem, and in fact maybe it is. But you see, left C loops there's not a lot of structure to them, so they give up their secrets fairly stubbornly, and this was kind of a long time coming. I don't have a name attributing the first discoverer of this theorem, because there are a couple of groups that got it, so I'll just leave it to the gods. It's a theorem. All right. I want to say something about the relationship between C and left C loops with a very famous variety of loops, Steiner loops. So first I should tell you what a Steiner loop is. So it's a loop that is alternative, commutative, and has exponent 2. And if some of those words are unfamiliar, I'll just say that these are intimately related with Steiner triple systems, which means that they're bound up tightly in the world of combinatorics, statistical design, and so on. So here's a theorem about C loops and Steiner loops. The quotient of a C loop by its nucleus is in fact a Steiner loop. So these C loops are heavily combinatorial variety of loops. Okay, so left Steiner loop doesn't, well, not yet. It doesn't appear in the literature. We coined this definition because of the theorem to come. You can probably anticipate it. But a left Steiner loop is left alternative, a loop that's left alternative and has exponent 2. We don't require commutativity. And we dub these things left Steiner for a variety of reasons. The main one is this. This is the new result. The quotient of a left C loop by its left nucleus, which in the previous slide we just noted is in fact normal, so the quotient makes sense. It's a left Steiner loop. So the left C loops are also kind of bound up in the world of combinatorics. All right, so I want now to say something about the nuclear square. So this is so So for the non-enthusiasts, this is almost arcane and esoteric, but it's a very small thing and subtle definition, but there's not very much structure here, so one has to be really careful to tease results out. So I'm introducing some notation, maybe this is a mess. Linguistically, it's a mouthful. But N and then the double subscript lambda and mu is just the intersection of the left and middle nucleus. So I don't think that there's a natural thing to call this. So I'm just going to call this guy the left middle nucleus. So you can probably guess the other definitions: the left right nucleus, and then the middle right nucleus. And I think that with that, I've got all three of them. They're the pairwise intersections of the left middle right nucleus. Okay. So if you have a loop with left and middle nuclear squares, so now it would be nice if I had that big messy Hasse diagram up on the board, but that's the LNS and the MNS. So you have a loop where squares are in both the left and the middle nucleus. Then the intersection of the left and middle nucleus is in fact normal. So which doesn't seem like a whole lot, but I'll come back to this. Oh, and then if you have just nuclear squares, not restricted to just two of the nuclei, like in all three of the nuclei, then the nucleus is in fact normal. Okay. So thinking back to that Hasse diagram of the 14 varieties, you could see that there's a natural analogy between left C loops and left bowl loops. As most of the enthusiasts will recall, the left bowl loops that satisfy the automorphic inverse property, which I've abbreviated AIP because it's shorter. Automorphic inverse property is a mouthful, but it's an easy property, just that the inverse mapping is an automorphism. So it's one of those very nicely named objects where the definition is in the name. The automorphic inverse property bowl loops turn out to be extraordinarily important and heavily structured, so much so they're given a name. They're called Bruck loops. They go by other names, but Bruck loop, I think, is the name that's stuck. I will say that then the obvious thing to do is to investigate the left C loops that satisfy this property. And indeed, you get some rather remarkable structures. So this will just be a slide, again, as I did with three theorems. I guess I've called them lemmas. So if you've reached your mathematical limit, it's entirely reasonable to not pay close attention to the next two lemmas, which are kind of technical, and only wait for the punchline, which comes in the third theorem, or the third result, which is the theorem. So if you have a loop with central squares, the automorphic inverse property is equivalent to requiring that the squaring map be endomorphism, which is a surprising result, kind of strong result. And now you can weaken it up just a little bit and loop with squares in two nuclei. If that loop has either the automorphic inverse property or endomorphic squaring, then squares are central. And by central, I mean nucleus and commute. And hence it has both AIP and endomorphic squaring. As I say, those results are a little bit technical, but not bad results, because there's not a whole lot of structure in it. You can tease out some mathematics and results. So here's the result, the new result. In fact, this is true of torsion loops, but I've stated it for finite loops with squares in two nuclei, and then either the automorphic inverse property or endomorphic squaring map. You can decompose the loop into a product of a two loop and a loop of odd order. So a really strong decomposition here. So it's a direct analog of well-known result for Bruck loops in a variety that's much less structured. All right. So I'm going to change gears quite a bit. I'm going to stay firmly solidly in the universe of bowl moving, but I'm leaving the world of loops, and I'm going to talk about rings, changing gears. So I put rings in the postmodern scare quotes, and here's why. So I reproduced the definition of the ring from any undergraduate algebra textbook. I don't like this definition for linguistic purposes. The third condition, the multiplication be associative, is gratuitous. So I'm going to drop the scare quotes and I'm going to drop the associativity to multiplication. And so if you want to work with a ring where the multiplication is associative, then please call it an associative ring. And I adopt this convention so that we can talk about rings that don't have to be associative without the cumbersome naming, not necessarily associative rings. So a ring, I'm not requiring it, I'm not saying anything about the multiplication of the ring. This is a little bit weird. This is entirely to make the language slicker. I want my rings to be unitary. I want them to have two-sided identity elements. And instead of saying unitary ring, I'll just require that we have two-sided identity elements, just to make it easier. So a ring, I'm not requiring associativity, I need an identity element. Okay, so same problem, but instead of applying, asking it about loops, I'm now asking it about rings. So what do these 60 different Bol-Mufang identities, how do they work out in the world of rings? And it's really surprising that, so this Hasse diagram is a little bit different from the loop ring, but the loop Hasse diagram, but it's really close. In fact, there are precisely 3 differences. I'll just tell them to you. There will not be a quiz afterwards, so it means nothing to you, don't worry about it. But I'll just tell you, with rings, extra and C are equivalent. And then the only other difference between the Hasse diagram for loops, surprisingly, is that left C rings imply the left pole law, and right C rings imply the right pole law. So it's a significant difference from loops. But otherwise, kind of surprisingly similar. So here I'll say something formally now about automated theorem provers and finite model builders. So to produce something like that, you need to produce a lot of proofs. And for the Hasse diagram that I just had up on the slide, the proofs are not hard. In fact, it's like a really good exercise to give to a student who's just learning how to use automated theorem provers. Fairly accessible proofs. The distinguishing examples, some of them are trivial, you can generate them with a computer fairly quickly, but others are huge, far too big for a computer to find, so you have to come up with a different way to think about them. What we use is sort of the idea of a group ring except applied to magnas, and I'm not even going to bother boring you with the definition there, but it's something like a group algebra idea. And then if there are any ring theory enthusiasts, I'll say that not surprisingly, the characteristic 2 played a prominent role. Some of the minimally sized distinguishing examples that we needed to get that classification had order 3 to the power 6, I guess, which is the number that's in the 700, 729. So I'm almost done. If you can recall the definition of a Lie algebra, and now instead of applying it to an algebra, you apply it to a ring, you get this standard definition. This is a Lie ring. So you have this bracket operation that satisfies these 3 identities, which are straight from Lie algebras. And so the natural question, the obvious question, is to classify the Lie rings of Bol-Mufang type. Okay, and so before I show you this Hasse diagram, I'll point out that this is an entirely natural, not artificial problem at all. The reason is because every single Lie ring is a Bol-Mufang type, and that's because they're all flexible. So you're not artificially narrowing the class of loops class of rings that you're investigating. So what I have on this slide, notice that I didn't, up at the top, I didn't attribute this result to anybody. And the reason I didn't is because it's not yet a theorem. So the implication, so you read it the same way you read the other diagrams. The implications are all relatively straightforward. We think that we've proven all pairs of identities that are equivalent. And we have, so I think that what we need is to make this work 30 distinguishing examples. And I think we have 16. And I think we need 14 more distinguishing examples. And the challenge here is that they're very large. So some of our examples, which were amazingly found by computer, I was surprised the computer could find examples of rings of size 2 to the power, so 128, 256, fairly large rings. But the computers so far not been helpful with a lot of these guys. So I would say that for computer scientists, this is my shameless plea, begging of computer scientists. I know that in the world of computer science, it's far more glamorous and sexy to work with automated deduction than it is with finite model builders. But for the practicing mathematician, the guys who roll their sleeves up and find examples, it would be a work of art, a gift from God, if somebody were to parallelize a finite model builder and allow us access to visual models. And with that, thank you.
Thank you a lot. Some questions, please? Okay. Not a lot of questions. Thank you again. Please.
What is clinically you work in a park?
Your English is fine, it's my ears.
Один группоист for the test, they exist 10 in power 100. GPT is good, but we working in cryptology and working in big powers. You can 10 it is little order. Gruppoid of order 10, gruppoid of order 10, they exist 1 power 100. 20. And GPT, we can to ask GPT can wait. So, what study Professor Phillips? He studies structure of quasi-groups, groups. By the way, was Professor Albert in power cube, Adrian Abraham Albert. He was specialist in cryptology. And loops means that Chicago loops. This was region in Chicago, very good fine value. And he named similarly to groups as loops. These results are good by my opinion. Professor Phillips did not give some little details, but in general he just said what means this structure and
Thank you, Professor Shapakov, for your intervention. And thank you again, Professor Phillips. And now our next invited speaker, our colleagues, Professor Vladimir. The main research domain is related to qualitative theory of differential equations.
And function differential equation. Please, Professor.
The title of my talk is two-sided remote almost periodic solutions for ordinary differential equations in planar spaces. Taking into consideration that this year we celebrate the centenary of Professor Vladimir Sherbakov, I dedicate my talk to this date. My talk consists of two parts. I will give a short view of Vladimir Sherbakov. The second part, properly two-sided remote almost periodic solutions of differential equations. At first, I present here some important facts and dates from biography of I'd like to note that he was one of the first collaborators. He worked here in 1961, between 1961 and 1964. After he continued his work in the framework of State University of Moldova. What is happening? In 1956, he obtained his university diplomas. In 1964, he defended his PhD thesis. In 1961, he became for habilitation. In 1962, he became a full professor of State University of Moldova. I'd like to present here some direction of his research in the calculus theory of differential equations and the theory of dynamical systems. First, he started his scientific work studying some problem of stability in the sense of Lyapunov, solutions of differential equation in the planar spaces. The second direction was the third direction was Poisson-stable solutions of differential equations. After he created the principle of comparability of both functions by character of recurrence, and using this principle, he studied problem of Poisson stability of solutions of differential equations. And finally, he published a series of work dedicated to the dynamical system with multi-dimensional time. I'd like to remark here that his works about Lyapunov stability of solutions in a planar space was attracted the attention of well-known mathematician Mark Grigorievich Crane. His included these results in his well-known book about stability, edited in 1960 in Soviet Union and translated in 1964 in the United States. I'd like to remark here that to solve the problem of quantum stability, he created a new method to study the non-autonomous differential equations. Jointly with Soviet American mathematicians George Sell, Seifert, Miller, Dobby. Approximately 1965 and later. I'd like to remark that in this year, a group of Moldavian mathematicians prepared I hope a special issue of Bulletin of Academy of Science of Republic of Moldova, dedicated to his center. I present here the more important applications of Borisov between them two monographs. And the more important, by my opinion, papers published in Soviet Union journals. And now, the second part of my talk. We consider the problem of existence of solutions of differential equations of the form where A is a linear bound operator, depending on time, Ft is constant term, epsilon is a small non-linear transformation. I refer here some standard definition, just the notion of relatively dense set. Using this notion, one introduced the notion of almost periodicity, a notion of remotely almost periodicity. Almost periodicity is a classical notion which was introduced by Danish mathematician Bohr in 1923. Formally, the definition is following. Function f is called remotely almost periodic if it admits a relatively dense set of epsilon translations. Epsilon translation, this means that translation of function f, initial function, the different uniformly on R, differently small than epsilon. The simplest example of almost periodic function is, of course, periodic function. But non-trivial example is, for example, the sum of two periodic functions with different periods if the periods are irrational independent. In this case, the sum of two periodic functions is almost periodic, but not periodic. Of course, the finite sum of periodic function is different period, which are not irrational dependent, is almost periodic, but not periodic. This theory is developed. There is a theory, deep theory of this function in solutions of differential equations. Relatively new is the notion of remotively almost periodicity. A function is called remotively almost periodic if formally definition is similar, but instead of distance, uniform closeness, uniform on the axis R, on take the distance the infinite. This means that physical for substantially large value of phi, function f became similar to almost periodic function. Infinity became real almost periodic function. But formally, definition is presented here. I give here two examples. One, of course, very almost periodic. Present a simple example of remote almost periodic function is not almost periodic. This means naturally that the set of remote almost periodic functions is much more bigger than the set of almost periodic functions. Here I make some remarks. This notion first it was introduced by Andrunachievici in 1986 for scalar functions. After for functions after function on the semi-axis was introduced in 1988 by Rees and Summers. Unfortunately, the theory of this type of functions and solutions of differential equations is not well developed. There is some results, but proper theory absent. The second part of my talk consists of three sections. First section. Here I present the two-sided remote almost periodic functions. Motion of the system and functions for any functions. The second part is dedicated to the study of remote almost periodic solutions of linear differential equations. A third part dedicated to the study of remote almost periodic solutions of non-linear perturbated linear equation. This means that we consider linear equation plus small non-linear perturbation. We study the solution, remote almost periodic solution for this type of equation. In this part, firstly, I recall some standard definitions from the theory of dynamical systems, namely the notion of the Lagrange tail motion. Lagrange tail motion is the motion is relatively compact. Second, I recall again the notion of the relative density set on the real axis. Third, I introduce here the notion of remote almost periodic motion and respectively remotely almost periodic motions for dynamical system. This is analogous for the respective definition for the function. I consider here an important example of dynamical system is one used to study the non-autonomous linear and non-linear differential equations. Namely, the dynamical system on the space of continuous functions. Sometimes this dynamic system is called Debt's dynamic system or shift dynamic system. For continuous function, we consider the family of all continuous functions defined on real axis R with value on the space, on the complex metric space X. Equivalent with the compact local topology can be represented, for example, by this distance in type C, defined as indicated below. This space is complex. This method generates a compact local topology. In this space, we define the notion of translational function. After using translational function, we define a group of translations or a dynamical system of translations for Debt's dynamical system. Using this dynamical system, this dynamical system is very useful to study many topological properties of functions. For example, periodicity, almost periodicity, remote almost periodicity, and so on. I forgot here, for example, one statement which establishes a relation between the property of given function and respectively motion. Every function, for example, phi, on this shift dynamical system generate some motion. A lemma 7 establishes the relation exactly. A motion generated by function phi is two-sided remote almost periodic if and only if the function phi as the function mapping from R to X is remote almost periodic in terms of sense. This means that we can use the ideal method of the property of function, for example, almost periodic. Analytical definition I give here for the function of two variables, the time and from point X from the definition, of course, with respect to time. For example, almost periodicity, is the time uniformly with respect to variable from past space. Now, section 2. In section 2, I consider the problem of existence of remotely almost periodic solutions of linear differential equations. A linear non-homogeneous. But I start by linear homogeneous equation 3. I introduce here an important notion for our study, the notion of exponential trichotomy. There is a well-known and well-studied notion of exponential dichotomy or hyperbolicity for linear equations. This notion, exponential trichotomy, is a generalization for this. I present here the formal definition, but geometrically this means the following. Equation 3 has exponential trichotomy if at first this equation has and dichotomy on semiotic R plus. At first, the same on semiotic R minus, and the stable and unstable manifolds has intersection transversal intersection. Three geometrical conditions: hyperbolic term positive direction, in negative direction, intersection of stable and unstable manifolds is transversal. In this case, one say that this equation has exponential trichotomy. Of course, if a equation has exponential dichotomy, automatically has an exponential trichotomy too. There is a simple example, one we have exponential trichotomy, but not exponential dichotomy. For the equation 3, which has an exponential trichotomy, one construct a green function. As for the equation is hyperbolic. But Elizabeth, well, this function, of course, is not unique. There exists at least one green function, but not only one, as in hyperbolic case. For example, y equal to 5 is defined a function which enables green function for equation 3, which has an exponential trichotomy. And using this green function, we can forward our test result. For linear non-homogeneous equation 6, assume that corresponding linear homogeneous equation has an exponential and operate the functions a, t, and forcing term f are removable two-sided removable almost period. In this case, linear non-homogeneous equation 6 admit at least one removable almost period. This solution is given by equality 7. First statement, second statement, every bounded solution of equation 6 is relatively almost periodic. In reality, not at least one, but every bounded solution in reality is relatively almost periodic for this. And now the third part of my talk, the third section. At first, I recall here the standard notion of ellipsis condition, or ellipsis condition global. So this is the function dependent of two parameters. Ellipsis condition is it's not something new, it's standard definitions. And now we consider a nonlinear perturbation equation 10. Equation 10, this is a, we have a linear equation, a small nonlinear perturbation, or in certain sense, small in certain sense, no nonlinear perturbation. Along this equation 10, we consider also solvent as class of this equation. As class, this means the family of equations 11, where B and J is the pair of functions belonging to the closure of family of all translations of functions A and F. It means that along with equation 10, we consider first the family of all translations A plus the limiting equation, family of limits of different types of translations. And now we can formulate our next result concerning the linear, non-linear equations. We consider at first we consider equation 12. I recall that here operator function at, forcing term ft, and nonlinear perturbation capital F as function of t are remotely removable. We suppose that the following conditions are fulfilled. First, the corresponding linear equation has exponential frequency. Second condition, the functions, operator function A, function forcing term F, nonlinear perturbation F, are Lagrange stable. The family of a third condition, nonlinear perturbation satisfy the Lipschitz condition with constant of Lipschitz sufficiently small. Sufficiently small, I indicate here corresponding restriction for Lipschitz constant. In this case, we have the following statement. First, the nonlinear admits at least one decided at least one. First, this solution is given by the following integral equation. A third condition, we give here the relation between solution of perturbed nonlinear equation and phi 0, this is the solution of linear equation, solution of linear equation. This is the estimate of difference of two solutions. Second results. We consider linear nonlinear equation containing this small parametric epsilon. Equation 60. Equation 14. Suppose that the function, operator function at, forcing term F and nonlinear perturbation capital F are cosine derivative almost stereo. A function capital F is globally consistent with respect to in this case, there is a positive number epsilon 0. That's the for such small epsilon. The equation 14 admit at least one remotely, two-side remotely almost solution by epsilon, at least one. This solution is given by equation respectively equality. A third statement, if the parameter epsilon go to 0, solution phi epsilon converges to phi 0. This is two-side derivative solution of equation 14 if epsilon equal to 0 for non-perturbed linear non-homogeneous. Now, I'd like to make some remarks about this presented above results. This theorem guarantees existence at least one, but not only one, two-side remote for sufficiently small epsilon. Below, I give a simple example. Consider that in reality there exists more than one two-side remote if epsilon is certain. For example, consider a function t equal to exponent of minus module. This is a example of two-side remote. Consider the respective non-linear equation 15, where epsilon is a positive non-negative number. It can be simple. We can calculate directly that this equation 15 admits a solution to epsilon t equal to. Parallelly, we have in reality three solutions for this equation. Trivial solution 0, two non-trivial solutions. One of them, one epsilon go to 0, and over 2 go to infinity. One epsilon go to 0, so relatively atmospheric solution go to infinity. Here I make some remarks about bibliography remarks. Analytical problem for linear for differential equation for in the finite dimensional case was studied by Castillo, Kostic, and Quinto. I indicate here respectively publication. But the important difference is for linear equation, suppose linear equation admits exponential dichotomy. Equation if admits bounded group is only one. In our case, maybe more than one. Even in the finite dimensional case. I present here a simple example of linear, scalar linear equation, non-autonomous. Of course, AT is a coefficient is arctangent of T. It is simple to verify that this equation has an exponential dichotomy, but not an exponential dichotomy. These examples show that the class of linear equation exponential dichotomy is much more large than equations with exponential dichotomy on R. I present here corresponding references. Thank you for your attention.
Thank you, Professor David. Some questions, please. No questions. Thank you, Jane. And before coffee break, I want to thank again all our invited speakers for interesting presentation and talks. And I ask you to go in front of the building for group photo. And after that, the coffee break will be at the second floor. All afternoon section will be in the building, in back building, in our building where the Institute of Mathematics and Computer Science is located. And all rooms are indicated in programs, last programs from the site. And now please go in front of the building, and after that to coffee break.
Надо мобильно использовать. Вот этот ролик, вот когда я запускал шер-скрин, у первого и у третьего зависли. Второй идеально читался. Третьему пришлось перезагружать режим. А первого